today, everybody, we're going to very quickly run through an innovation in capital markets, which we're looking at for transfer of risk and the management of risk in credit models. And what we're doing, we're isolating the physical risk. The way we've been looking at this is we've been thinking of physical risk having a whole series of attributes, one of which you may be familiar with sometimes, and climate change can contribute to physical risk, but we don't think of it the other way around. We think of physical risk as always having existed in the banking system, and the problem in physical risk is here and now. It's just the opacity of that because of the lack of data and models in the banking system to expose those vulnerabilities. And what we're going to demonstrate here is the first beta version of how we've actually built a framework to actually get all of this into the banking system using the underlying CDM model by extending it, have that as a foundation, and then on top of it, bring in all of these non-traditional data sets and non-traditional models so they can be used in the banking system consistent with the entire existing plumbing of banking. Okay, so I'm Johnny Mattimore, my colleague David Kelly.
Hello.
We're both mathematicians by training. We both started on trading floors, and we both spent a ton of time in risk. And our origins are not technology, our origins are in lines of business. And to give you the context for this, we got involved in FINOS a while ago because FINOS was interested in not just cost savings at the bottom line for technology, through technology, but also revenue generation for lines of business. Because the lines of business guys in the front office, they can't really control the bottom line costs, but they can generate more revenue. So what we're going to do here, we're going to highlight the problems that the CDM solves. That's the integration of physical risk data, identifying the assets at risk and their insurability, and then ultimately, how can you manage that risk by hedging and transferring. The agenda for today is some quick background to the problem, the objectives of our working group of extending the CDM to physical risk, and then the progress to date that we've made on a primary beta build. Okay, and the end game here is how do you create a liquid market in physical risk swaps. And the gross notional, we've estimated using some rather conservative data that this market is in at least tens of trillions of dollars. And to give you a context, the CDS market at its peak was $70 trillion. The global derivatives market, according to BIS, is around $500 trillion. Today, CDS, through compression technology and a reduction in speculation, is around net notional annually of around 10 to 11 trillion. So having a notional exposure in physical risk, which is one of the largest components of risk in the system, of 10 trillion is not unreasonable. Yeah? David, do you want to?
Yeah, so one of the issues here is the difference between climate risk and physical risk. So we are talking about the physical risk of mostly floods, but other hazards. But we're primarily focused on floods. And the main issue that we are seeing is if everybody's got insurance on their household, they'll know it's been going up. And in some extreme areas, that insurance has been withdrawn from particularly flood resistance or non-resistance areas. So the consequences of that is extremely societal, and that's really why we're sort of very keen to work with regulators as well as the banks. So the societal thing is that the cost of this increased insurance ends up on the taxpayer, and the cost of not being able to access affordable insurance is devastating. Not only just the value of the property, but its ability to be sold. So we see we've gone through the whole credit crisis in 2008, and we understand the excesses of the CDS market and the CDOs and all the long short and all that kind of governs. So we see that as we're seeing the same sort of trigger, we believe, in the flood risk world. And we see one of the solutions to that, or the primary solution to that, is not just building models or building product, it's building the data set and the structure, having a mutualized data structure in order for a market to evolve in the ability to transfer risk.
Yeah.
So what do we mean by flood risk? Most people think flood risk is the direct impact of flood on a particular property. And this is where we've had a disconnect in many ways, because your mortgage provider will say, listen, I'm lending out 20 years, but it doesn't matter about flood risk because insurance will pay for it. Well, yes and no. The insurance does pay for it, but lo and behold, the next year when your insurance premium goes through the roof. So what we define as physical risk, particularly around flood, is not just the direct impact, but the indirect impact of a property or an asset being uninsurable, where we talk about insurance flight or insurance withdrawal, and we believe that is the primary concern that we have. So the other aspect of this is we kind of see flood risk very much as an extension of credit. I think a lot of people in the past have seen it as it's a commodity, it's like weather swaps and LIA. It's not. It really is not at the end of the day. It is, what is the impact of flood risk have on the PD's probability of default and the loss given default? So loss given default is obvious, the value of your asset collapses, but the PD is quite an interesting one because we're not talking about traditional credit, which is people default because they get divorced, they have illness and lose jobs, all those kind of things. This is the strategic default when they say, it's just not worth having this property anymore. I'm leaving the keys and I'm walking away. I think that's one of the more interesting nuances, if that's the right word, that the industry hasn't quite grappled with yet. And that's what we are looking at in some detail.
So we've really simplified the way of analysing this. We put the market into two extremes, for good or wrong. Banks like to operate where a spring always bounces back. We all know Hooke's law. You pull a spring too much, we did it as children, you just bust the spring and then you get a clip round the head from the parents for breaking something. The extreme stretching of a spring is very much the domain of the catastrophe market. Banks aren't in the industry and the business of writing extreme risk. Banks want repeatable, functioning business where they only occasionally get some provisioning for extreme things that they didn't quite capture. This middle ground where it's overstretched, it doesn't totally deform to a biblical flood disaster, but neither does it bounce back to being the same BAU as they've previously known. You're getting clusters in portfolios where the collateral is getting degraded over time through incremental risk events, hazard events. And what we're very interested in solving is how do you bridge this gap between banks not wanting first loss in any transaction, the green box, and banks expecting insurance to take the extreme losses on when something's destroyed or severely impaired. That middle ground didn't used to be very congested because we didn't have such concentrations of properties, such conurbation concentrations, such urban expansion. And what we're having compounded with potential changing weather events, for whatever cause those weather events may have, is a greater concentration in this amber region. And that's what banks are recognizing as a huge risk. And what we've done, we've given a framework of every crisis we've ever worked on and studied historically. And that's systemic risks, what is the solution to those risks, and what's the recovery. And we've mapped to this framework what happens in insurance using residential real estate can be extended to commercial and other industrial assets. But you'll see, as the hazard risk increases, insurance retreats. It retreats by either hiking up the prices or completely evacuating. Now, then you've got massive exposure on these long-dated mortgages, you've got a degradation in the collateral, and you've got banks seeking ways of hedging portfolio exposures they never expected to have. Vendor solutions, very good at identifying risk. They're not solutions to actually do the risk transfer when you've identified it or to hedge, but they are absolutely a critical component in the solution, and Davey's demo will show that. So our systemic solution is entirely open source. We use the CDM as a standardized model. We go up through FINOS standard open architecture governance. We have model governance. Those of you who know banking, model governance is one of the strictest in the world, full transparency, mathematical. There's no IP in model governance. The IP is in the implementation. And then you go right up to how do you implement the transactions. Well, that's ISDA's role on swap documentation and the whole standardization across the industry, because then you get critical mass for a whole market to interact and trade and transfer risk. The recovery then, because you've transferred the risk and we've defined the physical risk swap, you get resilience investment coming in. Instead of people walking away from properties, they can see that there's a hedge in place, so they can have the time to invest for 3 or 5 years, flood defences or any other type of investment, with a confidence that the hedges will cover the risk of the return on the investment. Then you get a recovery of a more sustainable, enduring property market, and then insurance returns to the sector. And we're looking at this where we have interoperability between the banking system for physical risk swaps and the insurance system for parametric insurance, because then you've increased the capacity for the whole system. And you don't have the concentration risk that we had previously, where all the CDSs ended up with AIG. Okay, and then this is a very simple structure of how a bank looks, and we've done it along 3 pillars: Pillar 3, Pillar 2, Pillar 1, to align with the BIS standards and Basel standards. So in Pillar 1, we're talking about reporting. In Pillar 2, we need the real analytics so that you can talk about buffer capital. And then Pillar 1 is the core Tier 1 capital. And Tier 1 capital has been completely proven that if you want to relieve that capital, you must show the efficacy of risk transfer. And this was done in the 90s, first by JP Morgan under the first ever collateralized debt obligations, which transferred risk off their balance sheet to end owners, investors. That meant it freed up capital to raise their Tier 1 capital ratios and also allowed them to do more business while dissipating risk across the system and removing concentration. Okay, and here's a quick summary for you to read at your leisure. This will all be available. But CDM is, the objectives here are to make it a standard, make it the foundation for physical risk as the only viable way to get it into the banking system, and to deliver immediate benefits for banks. And the rest just follows the sequence of what I've described. And now I'm going to hand over to David to take you straight into the technology stack that we've been developing.
Thank you. So we recently sent out invitations to be founding members of the CDM working group. And this is for physical risk. So there's quite a few CDMs that we need to build here in order to achieve this. So primarily, we are looking at the first 3, which are properties, mortgages, and gauges, which is somewhat odd, you might ask. But I will come on to why gauges is actually quite critical in this whole design thing.
You have 1 minute for this slide, David.
Okay. So properties. So what we want to do is we want to separate the instrument from the asset. So mortgages tend to be sort of linked in with the properties. In classic FINOS hierarchy approach, you have a mortgage, which is a financial asset, and it links to the property, which is the asset itself. So the separation is, as I said, is classic FINOS CDM. So we need to work with, we built our own beta versions of this, but we now have to get them validated and finessed, if that's the right word, with founding members from the financial institutions. So Johnny mentioned interoperability. And really that means that the way we're going with physical risk swaps is that it is a capital markets version of what is called parametric insurance. So that interoperability means that we are talking to the groups like Oasis, that is FINOS's sort of cousin in the insurance world. So we're looking at how we take the properties, mortgages, gauges, and then link it into a CDM version of a and a parametric insurance. So from that, a physical risk swap is a simple basket of parametric insurance. So, but it has to look and feel like a CDS because the infrastructure is there for CDSs, and we have to do a little bit of changing. We don't have issuers, we have gauges, we don't have defaults, we have severe levels. So that's really what we're going to be doing towards the end of the year. So it's build an infrastructure. As said, we've got beta versions which we will demo shortly. And then the final sentence is, what does quote it look like at the end of this? We want to switch from direct insurance to what we call basis. So if everybody knows this, all trading in banking is based on basis. You have an index which is tradable, and everything is valued as a basis from what is tradable. And we are planning to do the same here. So we're looking at indices for the Thames, the Seine, Rhone, Clyde, Humber apparently should do as well. And we're looking at that, and then we're looking at how do you take a basket of a portfolio of properties and how you define its flood risk as a basis to the flood risk of the nearby river. So this is just classic how trading works.
That's what gives us scale, isn't it, by the basis. If you try to do everything bespoke, you'd never have liquidity depth.
That's exactly.
Scale.
You cannot create a point of liquidity unless it's standardized.
I'm going to the next slide.
You're pushing me along, aren't you? So
this could just be for information, given
this is a bit of information. If there's one statistic, because this is a world which throws statistics around quite a lot. The one I really think about is it keeps them coming up. It's 1 in 6 properties are subject to flood risk. 1 in 6, and that's in the UK, large parts of US, not just Florida. It just keeps on coming up. 1 in 6 properties. Now, the solution to that currently is you, the taxpayer, pays for the insurance because we have flood re in the UK and we have something equivalent in the US, etc. It's not sustainable. It's really not sustainable.
We'll have to move.
So yeah, the 1 in 6 is the main one to think about here. So I'm being pushed along, aren't I? So the great thing about CDM is the fact that it all fits together. And this gives you an example of how we are taking some areas which are already standardized. So in weather predictions, terrain, these kind of things that anybody in the flood world would recognize, those are standardized. And what we are doing is using that to define what we call gauge time series. So it's very similar to market data. So that's, again, it's about how to make these things work with inside a capital markets risk infrastructure. And as I say, we talked about property, mortgages, insurance, and pops at the bottom, hopefully, is your physical risk swap.
And we've built a full version 1 of all of these, haven't we?
Yes, they all exist.
I'm going to jump forward.
Okay, so no pressure then, David.
This is why CDM matters.
So for the first time in this industry, we're actually thinking about, I'm not saying CDM is the Dell thing, but it's the infrastructure, it is the things that are important, is to get those things in place before a market takes off. And we don't want to repeat the mistakes we've made in the past. The market kicks off and nothing's standardized, there's no legal enforceability, the data doesn't flow. So this is why it fits perfectly not only into that sort of mindset from day one, it accelerates the adoption, but it also links into the regulatory risk reporting components from day one. And I would say that's the first time common sense has taken center stage.
I would say every product we've ever been involved with in cap markets, you and I, it's been shoehorned in, and then we've had a total spaghetti machine.
Yes.
The next 5 years.
1 or 2 of you are smiling because they all know.
Yeah. Your lives have been miserable too.
Yes, there's the consequences of shoehorning, which we want to minimise here. So Johnny, do you want to introduce this?
So what we've done now, we've packaged up a demo to show all of this theory in real life. Okay, and this is how to bring for an entire banking asset book, how you bring measuring and modelling of flood risk to life without huge...
Can I make a caveat here?
Go on.
I did this. I'm not very good at this, so... Thank you, Johnny. Today, I'll demonstrate the MKM Labs Physical Risk Program, a flood modelling system that measures and models flood risk based on the CDM foundations. Okay, looking at the code structure, our flood platform creates 3 core CDM types. This is property, mortgage, and flood gauge. It also generates flood events from gauge readings into time series. The portfolio section creates sample data, while our model section up here propagates floods across terrain, calculates property damage using OS climate vulnerability curves, and runs mortgage pricing models measuring PDs and LGD upticks. We've also built interactive tools to showcase today. So I'm running our portfolio builder, which creates CDMs and generates realistic collections of properties with mortgages, floodgates, and storm surges. This model water flow leading to gauge time series that exceed severe warning thresholds. We're also launching our portfolio flood analytics model. So these JSON files contain our detailed CDMs. This complexity is intentional, as we've unified requirements from mortgage teams, insurance providers, and local government into one comprehensive structure. All gauge data follows UK government standards. So let's kick off the visualization tools. So this is a summary report of that flood analysis, showing the typical distributions that you would put in a disclosure type report. Flood risk map is something we've just developed a few days ago, and the idea is that we can go down to individual properties to review their flood potential. So we have here a high risk level, 1.3 meters, is enough to create considerable damage. If we transfer to the interactive visualization, which is the main piece of kit that we have, we can see a red mist, which is the storm progression, starts in Bristol and ends in Margate. And as you can see, we have a portfolio of properties in and around London. So let me dive in a little bit. You see we've got all our properties with their basic information. And if we right click, we can generate our own report. And the report is long and considerable based on the depth of information that is available within the CDM for property, mortgage, etc. We can also do the same with gauges, give us a bit more information. This one is fully operational. And we can pick out a gauge that is not operational. And we can say it's temporarily offline. So again, this type of information is critical for any legally enforceability of currently parametric insurance. This entire analysis from data generation to detailed reporting was completed in seconds, and it's largely thanks to CDM adoption. And the solution design is now quite standard, i.e. the use of time series. Our next phase connects the real flood events, translating them into accurate gauge readings through scenario generation. We're leveraging parametric insurance capabilities from OASIS, which is the equivalent of FINOS for insurance, to create results distributions with tail sets just below the biblical events typical covered by catastrophe insurance. These developments enable capital markets to develop flood risk transfer mechanisms, which we call physical risk swaps. We're partnering also with flood modeling experts to enhance terrain expertise, measuring the basis risk between gauge level defined floods
and portfolio asset impacts. This, we believe, represents the future of physical risk in capital markets. And on that point, back to you, Johnny.
Right, so we're tight on time here. I'm just going to quickly jump back to our deck. We've done the demo. The key thing here is how do we actually get this into a banking system? You don't get there without proper flow from operations to model risk governance. And David and I have considerable experience in this, so we can codify this also. What we're going to do is just give you a quick summary. What we're solving here isn't an isolated project, it's the entire banking system. And it's in accordance with the strategic goals of FINOS. Everything open source, everything completely transparent, and everything that will be fit for the existing plumbing of the banking system. It just plugs in. So with the conclusion, CDM, think of it, it's much more than a data model. And if we pull this off, physical risk will change risk management in the banking system forever. And with that, we'll open for any questions if we've got a couple of minutes. No, we're a bit tight. These are all the CDM models, and they're all in a GitHub, and everything in here is accessible through FINOS. One question? Do we have time for one question? Yeah? Any questions?
It's quite a lot to take in.
Yeah.
If anybody's interested, there's a book you can download.
The book is actually a technical specification document which we've made open source, because you cannot take something like this forward unless lots of people can take the technical specification and completely modify it or extend it. So we took the inspiration from JP Morgan in the mid-90s, what they did with CDOs and value at risk, and we've produced a 300-page technical document. And it's not our view of the world. We've spoken over 5 years with hundreds of individuals at over 100 firms, and we've collated their feedback into this. So it's not an idiosyncratic opinion. This is highly representative of the banking system.
What John is actually saying is it's not my original work, but thanks for that.
Well, you're not getting royalties. It's free. It's open source.
Yeah, it's an open source book. We donated to.
And now we're working with members of FINOS, the larger flow monster capital markets banks, to assess the viability of doing a first transaction of this nature. And then once we get it up to scale, then we'd work with ISDA for the standardized templates, and then we would look at a market service where the banks actually share the actual burden of the computational effort, which is not inconsiderable when you're moving from doing a compute once a year for catastrophe modeling to doing a revaluation on a daily basis with time series and probability distributions into banks. Very intensive. So we're working with NVIDIA. Another example is one of the leading flood providers in the world, JBA Risk Management. These are the real catalyst firms that are going to make this happen. I would say there are less than 5 firms in the world we can work with to make this happen. Okay. So with that, any questions? Ask David. I'll be at the beach. Thank you very much.
Thank you for your kind attention.